Welcome to the satellite communication course. So today we start a new model 5, Earth Station Technology. Now in this model we will learn that what are the various transmitter, what are the various receivers are there for the Earth Station, everything related to the Earth Station, transmitters and receivers at the Earth Station, and then what are the various antennas we are using for those Earth Station, and what are the various tracking systems required for this Earth Station we will learn here. Now, generally, that Earth station is nothing but a mediator between that a users and a satellite there. So that's why generally we can say that a Earth station is the gateway to the terrestrial link. Means what? That terrestrial links are nothing but link from the users to the satellite or satellite to the users. Now, if you see that elements of that Earth station, so in that case we have the terrestrial model, and the terrestrial model that will be a terrestrial interface model from the various users. That's supposed to be the give the output to the your Earth station. So we see that terrestrial interface model, they have the various inputs, or you can say that there are the different sources, and that input is given to the Earth station, and then Earth station transmit the signal to the satellite. Now that is about a process of transmission of signal from the user, the multiple users. Multiple users means what? A different sources. You can say that different source input, and that will be the input to the Earth station, and then Earth station transmit the signal to the satellite. That is about the process. Now we can say that there are the various inputs, and that is the terrestrial interface model to the Earth station, and then there will be different sources or a different signals that is to be transmitted through the Earth station to the satellite there. Then the role of a satellite here what? Whichever the signal received from this a terrestrial interface or a terrestrial model, and then satellite process the signal, and then appropriately process signal will transmit it, and then they will be transmitted again to the users. That is about a process. Here we can say that this Earth station is nothing but a gateway or a mediator from the users and a satellite there. So now, what are the various Earth stations that will communicate a users through the different sources that we'll learn here. Suppose if we consider that the Earth station is on the ground, then a users, many users are there, they will transmit to the another user through the satellite. Then if supposed to be we are going to communicate through the aircraft there, then in that case a aircraft can be act as in a station, and their users and aircraft, and then a satellite. Means here in this case a earth station will be that aircraft will be act as a station, earth station. So you will communicate to the aircraft, then aircraft will communicate through the satellite to the users there. So that is nothing but what we can say that a aeronautical satellite communication. If supposed to be instead of that aircraft, if supposed to be there will be a ship, then a ship is considered as a earth station, and then users can communicate through that ship through the satellite, and that communication is called as a maritime communication. So that's why that what are the various types of a earth station, whether that earth station is located or situated on a ground, that earth station is called as a ground earth station. Okay, because we can say that a ground earth station, if it is on the land or it is on the ground, then that earth station is called as a ground earth station. If we supposed to be consider that that station is on the aircraft, then in that case, aircraft earth station. If the station is present on the ship, then in that case we can say that a ship earth station. So now that earth station, even if whether it is presented on the ground, aircraft or a ship, but that earth station, they have some component, that subsystem component, and that subsystem component that will process the signal, and once that signal process, then they will transmit from the that particular station to the satellite, and then from the satellite to the earth station there. Which signal processing will take place at itself at earth station as well as at a satellite, and then a communication takes place from a satellite to ground or from the ground to satellite. So then processing will take place at the both the end, and then we can say that that earth station is in ground, aircraft or ship, that is a station categorized based on the placement or based on the location of the earth station. Now another way is about to categorize the earth station, that will be based on the what will be the type of an antenna there. If supposed to be that a size of that antenna is large, then that earth station, we can say that type of earth station based on that antenna size. If that antenna size is large, larger station. If antenna size is a medium, medium earth station. If antenna size is a small, then a small earth station. So then we can say that an earth station can be a large or a small. Small, we can say that we have that is a size of an earth station, that antenna, whether it is a small or a large, or whether that antenna is a fixed or that antenna is a mobile one. So that's why we can say that a type of earth station, it is basically depending upon that what will be the antenna there. So we can consider that a antenna, whether it is large or small, but again that whatever the subsystem components present in an earth station, that subsystem components are remain constant or it remains same irrespective of the size of the antenna there. or irrespective of that size of that earth station. So now we start here to learn that what are the elements of an earth station. Now we say that basic elements to the earth station, that is nothing but interface from the users to the terrestrial interface. Here we have the multiple users. Then we can say that a terrestrial interface, and from the terrestrial interface, then we have the is baseband system. Then that will be baseband system is nothing to be a control with respect to that whatever the antenna position or antenna system is there. Then we have a antenna system, and after that, that is the input given to the earth station. That is about the antenna here. From the baseband system, we have a transmit system. From the transmit to the antenna system here, and then we have the receive system. Now, if you see here, that earth station is used to transmit the signal from a terrestrial sources to the satellite. Here we have the antenna here. Means we have the multiple users, that is multiple users from what we can say that a terrestrial system that transmit the signal to the satellite here. So this is about the earth station component. Along with that, on the earth station component, we have the power requirement for this each and every component. That is a power system. Then monitoring a component or monitoring the system. So this is nothing but the block diagram of an earth station there. Now a users, we say that, transmit a signal through this terrestrial interface model to the satellite through an antenna. This is nothing but a earth station. And then if any signal received from the satellite, that is that will be received from this antenna, received from this receive system, and then it will be transmitted to the users like. Means both the way here. Means earth station, it has a transmitter as well as the receiver there. And then we can say that basic component, main component of this earth station here, that is a antenna here. So now it will transmit the signal as well as it will receive the signal. And then we have this baseband model, and that will interface the users for, for transmitting as well as receiving the system there. So means we can say that from the terrestrial side, the earth station received the signal from this various terrestrial component or a terrestrial systems, or that earth station will transmit the signal to the terrestrial system that will be received from the satellite. So means we can say that this multiple users or this multiple signal or different sources of a signal, that can be, we can say that it can be either a telephonic speech, or it can be a audio, or it can be a video, or it can be what, television signal, or we can say that a data from a computer. Okay. So now that is about a multiple input, telephonic speech, audio, video, television signal, data from the various components, and that is nothing but the user interface here. And then that input is given to the earth station. So now whichever the signal received here from this terrestrial interface or this multiple user there, and that signals are here formatted, and that will signals will be modulated here, and that modulated signal with an intermediate frequency IF, that will be given to the baseband system. And then that IF signal or intermediate frequency signal in that particular baseband system, that will be transmitted. So that's why we need a up converter here. When we transmit the signal, we require the up converter, and then a amplified, and after that, that will be transmitted. So here we can consider here that high power amplifier is used, and that high power signal, that will be sent to the antenna system, and then that antenna system will transmit that high power signal to the satellite. And then this is about the transmission system from the user to the terrestrial interface model. Then signal will be up converted, then amplified, and then transmitted to the satellite. That is about the transmission process. Then similarly at the reception, a signal will be received. That signal received from the satellite, that will be a low power signal. So that's why we can say that a low power signal will be received from the satellite, that will be amplified. So we can say that here we have a received signal first, it will be amplified, and that signal will be amplified with a low noise amplifier. That's why we can say that a LNB here, that is a low noise amplifier, and then that will be a down converter. And that signal will be down converted to an whatever the intermediate frequency, that is about a IF here, and then that will be sent to the baseband system. So means we can say that here we have the IF that will be given to the baseband system, and then whichever the IF is received, that will be demodulated, and then that baseband signal will be transmitted to the terrestrial interface unit. So now that is about a reception system. So that we can say that a transmission up converted, amplified. Similarly, we have receive, amplifying signal with a low noise amplifier, then down converted, and that will be interfaced to the user there. Now these are about the basic earth station component. So along with that basic earth station component, so earth station also has a power system, and that power system will provide a power to all the system components, and then that power to all the system component, that will be uninterrupted power supply to the all the system component then again it has a monitoring system. That monitoring system is used to check the health of each and every component that will be present in the earth station. So that is about a transmitting earth station. Then here a control system is here. So that control system is used to just switching that system for the transmission as well as the receiver, and then whichever the baseband components are there, that baseband component will be switch on or switch off, or that will be controlled to this control system there. And this again, the role of this particular control system is to rotate the antenna, because that antenna position to be fixed toward the satellite there, or antenna is to track the satellite, so that that antenna is to be aligned to the satellite there. So if that satellite is aligned toward to this earth station antenna, then the maximum signal will be transmitted to the satellite, or a maximum signal will be received from the satellite. That is about the role of the control system. Now these are the basic elements of an earth station. Now we'll see that a one by one component of this earth station system. So before understanding or learning the various components of an earth station, we need to know about what are the various types of an earth station, and then we will see that what are the various component of an earth station there. So we start here with learning that a type of earth station first. Now that a type of a earth station, we say that earlier, that will be classified based on the size of an antenna there. So that's how you can say that if that antenna size is large, then that earth station is called as a large earth station. If that antenna size is a small, sorry, we'll first see medium. If that antenna size is a medium, then we can say that a medium earth station. If that antenna size is a small, then we can say that a small earth station. Now these are the types of an earth station based on the size of the antenna there. Now that size of the antenna again consists of, or that will be considered for a number of users or a traffic handling. So means we can say that the role of that antenna, that will be directly to be considered on the traffic handling capacity of the earth station there. So number of channels that will be transmitted from that antenna, that is depending upon that size of an antenna there. So that's why we can consider that a large earth station, that the antenna size is large, so that a channel capacity by this earth station will be a larger. So means we can say that a large earth station, that antenna size is large, so that's why that large earth station, that will be useful for the variety of application. Because the size of an antenna is large, or channel capacity is large, or traffic handling capacity is large, so that's why that large earth station has a variety of a application there. And that large earth station, they have a more subsystem component. It has a more subsystem component than the small earth station. Okay, so that's why we can say that this large earth station, that will be support a variety of application because it has a more subsystem component there. And this large earth station, says that size of an antenna is large, so that's why that earth station has a fixed structure to support the large antenna there. And again, it has a control system, or a control room for this controlling the variety of these applications there. Since that large antenna is there, so we require that control system to direct the antenna towards the satellite there. So that's why that large antenna, or large antenna structure, it should be a fully steerable. Steerable means what? In terms of what we can say that means it is to be directing toward the satellite there. So that's why we can say that to get that a maximum power, or we can say that direction toward this, and that will be steerable. That's why we can say that steerable in the direction of what? A specific azimuth, or a elevation there. We can say that that antenna structure is to be a steerable. So once with steering the antenna there, then we have the control system, and that control system is automatically track that satellite, or we can say that that steering of an antenna, that will be carried out with a servo system to automatically track the satellite there. So for this given large earth station antenna, so we need to specify, or choose the placement of that earth station, or a location of an earth station, to minimize the interference from the ground system. So supposed to be that particular ground system, they have the various radiating element, or that radiating elements in that particular frequency band there that is used by this earth station. So in that case, there will be large interference. So that's why that large earth station is to be located where no interference or less interference is there. Generally, that ideal location of this large earth station that would be in a valley surrounded by hills and that has a proper azimuth and a elevation there. So if supposed to be that a large earth station has a minimum elevation angle, then interference will be a minimum there. If it is that earth station is kept on the hill, suppose, because we will get that high altitude because of that hills, and because of that high altitude, so that will not obstructing any path from the earth station to the satellite there. So that's why that large earth stations are designed in such a way that so it will carry the high number of channels or high volume, and that will be useful for the communication there. So we can generally say that a large earth station that has a number of channels, number of TV channels or a number of telephone channels will be large there. So then that large earth station will supposed to be useful for the domestic as well as the international traffic there. Then again, we consider that because of that a large channel capacity is there, so that's why you can say that that large earth station they have the various subcomponents as we say earlier. So that's why a large earth station they have the a one or more transmitter. Similarly, they have a one or more receiver there, and that is depending upon that how many carriers are transmitted or received by this earth station there. That is about a large earth station. Then we come to the topic next is about a medium earth station, and that medium earth stations that is used in a fixed location there, and that again it can be mounted on trucks, or we can say that it is nothing but a transportable here. That mounted truck, that antenna is mounted on the truck, or that system is mounted on the truck, it is just like a transportable. That truck is transportable for a temporary connection or a temporary link between the satellite there. So that is about a medium earth station. Even we can say that that is just like used in a war and all. That is a medium earth station. The system is transmitted to provide the coverage to the various places there. Or just like we can say that it is just like a whatever we can say that that is radar applications and all. If you see that earth stations are mounted there. Okay, likewise. Then we can say that a small earth station. Based on this large, medium, and a small antenna size, according that they have the various types of an antenna. Sorry, various types of an earth station. Now, in the case of a small earth station, that small earth station have the a small antenna, as we have said that, and it has a single transmitter as well as a receiver there. So that will be used to communicate that single transmission or single transmitter and receiver that is used to communicate to the satellite there. And that a small earth station generally, if you see that, that is used by the a corporator or that is used by the individual to receive the signal or that is useful for the communication there. So that is example is about a VSAT here, or we can say that we can have the emergency uh, or we can say that a portable station or emergency station or that can be used for the communication there. So it is not just like a small station that can be movable or that can be used for the communication or broadcasting their signals there. So specifically that earth station that can be used at a location, any location or anywhere in the place there. So it has a small model there. So that's why you can say that is about a VSAT there. So it has a small antenna and that can be used in a disaster location or any location there. So based on that, we can say that if we have the types of an earth station, so then we will talk about it, what are the features of the earth station. And that features of a earth station based on that a different types of an earth station and the different types of an earth station that is depending upon that antenna there. So we'll say their parameter, then we'll talk about that whether that antenna is large, whether we can say that antenna is small or a medium, likewise. So parameter is nothing but what? A antenna size. In that case, we'll consider that a diameter now. So that it is about a 15-meter and above, then 5 to 15-meter, then up to 5 meter. Then in this case, antenna tracking system, it is about a fully steerable and it will be a servo controlled. So in that case, limited steerability or you can say that step track control. So this one is about a fixed one or we can say that a manual steering. Then what are the various feeding is used for this antenna? So feed system, that can be horn or a sub reflector here. And then it has a feed system is about a some mode, or it has a prime focal. Then a high power amplifier use, it will be used a klystron, then a traveling tube amplifier, then solid state power amplifier. Then a power, that is a 3 kilowatt, then 100 to 400 watt, 1 to 10 watt. Then we can say that the applications are fixed traffic and all. Here it has the application fixed, and it is a transportable. So this one is a transportable, or we can use for the emergency application, or we can use for the BSAT. So that is about a earth station, and that earth station features we are learning. Now we'll talk about that a earth station transmitter here, whether we can consider that whether that earth station is a small earth station or a large earth station or a medium earth station there. Along with that, we can talk about that a low noise amplifier, or a low noise amplifier noise temperature, and that will be of a 30K, a 45K, and here it is about a 65K. So that is about your a earth station. And now next we can talk about that a earth station transmission transmitter here. And now we'll see here that a large earth station.